Hello, this is Stefan again from schristoph.online. Today we'll talk about my latest blog post on why agent memory is a spectrum, not a switch. When people say their agent keeps forgetting things, that is usually not a model problem. It's a memory architecture problem, and the design space is wider than just remembering the conversation. The neuroscientist Artem Kirsanov frames it well. In this video, he shows that a classic feed-forward network has no concept of time. It classifies each movie frame perfectly while having no idea the previous frame existed, like an expert with retrograde amnesia. His fix is architectural. Build sequence into the system on purpose. The lesson generalizes memory is not a free property that falls out of a big enough model. So where does memory actually live? Researchers categorize agent memory much the way psychologists categorize human memory. The most cited source is the Koehler paper, Cognitive Architectures for Language Agents, from a team at Princeton, which IBM's overview summarizes well. 4 types come up again and again: working, semantic, procedural, and episodic. Let me switch to the primary source this builds on. This is the Koehler paper on ArcViv by Soomers, Yao, Narasimhan, and Griffiths at Princeton. It lays out the cognitive architecture taxonomy that the whole spectrum borrows from. The taxonomy is theirs, the practitioner framing is mine. And here's IBM's overview, which summarizes those same 4 memory types in plain language. Importantly, IBM and Koehler treat episodic, semantic, and procedural memory as 3 siblings under long-term memory, not as strictly ordered stages. Keep that caveat in mind as we climb the ladder. Here's the spectrum as a ladder of increasing persistence. At the bottom, no memory at all, a stateless call. Then working memory, the context window, then episodic, a distilled record of what happened, then procedural, how to do a task, and at the top, semantic memory, a durable knowledge base. Read it as a menu of persistence levels you can mix, not a staircase you must climb in order. The whole point of the spectrum is that each rung has a concrete implementation. No memory is a stateless call. Working memory is the context window. Episodic memory is a distilled event store. Procedural memory is skill files with progressive disclosure. And semantic memory is Markdown, a vector store, or a knowledge graph. Name the rung and you can pick the mechanism. You might ask, isn't this just RAG with extra steps? It isn't. Retrieval augmented generation is one mechanism for the semantic rung, retrieving facts at query time. It is not a synonym for agent memory. An agent can have excellent RAG and still have no episodic or procedural memory, which is exactly why it keeps rediscovering the same solutions. This is not theory for me. My day-to-day runs on Keras CLI with an Obsidian Vault, and it maps onto the spectrum cleanly. Working memory is the live session. Semantic memory is the vault, hundreds of linked nodes loaded as context. Procedural memory is the set of Keras skills. Steering and hooks are refined between sessions. When a workflow goes wrong once, I encode the fix, and the next session does it right. Here's the sharpest objection. Isn't calling it a spectrum misleading? If the types aren't actually sequential, fair? Koehler treats episodic, semantic, and procedural as siblings, not ordered stages. A coding agent often needs procedural memory before it needs a knowledge graph. So the latter is a design aid for reasoning about persistence, not a required order. A menu, not a staircase. The rung that turns memory into something resembling learning is the bridge from episodic to procedural. An agent that reviews what it did, finds the patterns, and writes them back as reusable skills. Davide Galitelli published a clear reference implementation of exactly this on Amazon Bedrock AgentCore. It mirrors how sleep consolidates the day, the raw episodes fade, the lessons stay. That's the subject of part 3. The spectrum is vendor neutral, but each rung has a natural home in the AWS toolkit, and these are capabilities to reach for. Working memory is the model's context window on Amazon Bedrock. Semantic memory maps to Amazon Bedrock knowledge bases. With Amazon Neptune, when the knowledge is graph-shaped, episodic and procedural memory are what Amazon Bedrock AgentCore Memory is built for. Here are the AgentCore Memory docs. It provides short-term memory within a session and long-term memory that persists and is extracted across sessions. So agents carry forward what they learned. The managed service exists precisely so you don't hand-roll a session store and a consolidation pipeline before you've validated the idea. But context windows keep growing, so why not just put everything in the prompt? Because that collapses 4 distinct memory functions onto one volatile rung. Everything in the context window vanishes at session end, cost grows as you fill it, and large prompts degrade reliability. A bigger window raises the working memory ceiling, but per the spectrum, that is still one rung. So the next time an agent keeps forgetting, resist the urge to turn up the context window. Ask which rung the missing capability lives on. This session, past sessions, how to do a recurring task, or a body of facts, name the rung, then pick the mechanism. That single reframe turns a vague complaint into an architectural decision you can actually make. Thanks for listening. I hope this was helpful. If so, you can reach out on LinkedIn directly or head to my blog at schristoph.online. Let's keep in touch. Take care.